Hello students, welcome to Educate. Today we are going to continue with the question number 13 of chapter 6 of NCERT Physics. Here question says a rope of negligible mass is wound round a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? What is the linear acceleration of the rope? Assume that there is no slipping. So here we would like to discuss the concepts that we are going to make use. So here the first thing, mass is given as 3 kg and radius is given as 0.4 meter. Then angular momentum is to be found and F is given as 30 Newton. And what else? What is linear acceleration? So linear acceleration is given by A is also to be found. And if you remember, A equal to R alpha. So from here we can find A easily, provided we have alpha, and torque equal to I alpha, and torque is also F into R. So these are basic relations that we are going to make use. So let's proceed one by one. So first of all, let's find out what is torque. Force is given and distance is given. So torque will be force is 30 into 0.4. This gives 12 Newton meter. So one thing you have got. Now second thing we need, moment of inertia. So what is moment of inertia? Here we are talking about which figure? Figure is cylinder. So half mr square. So 1 by 2, mass of cylinder is given 3 kg and distance square, here this you have to take, so 40, 0.4 square. So this will become 3 into 4 into 4 divided by 2 into 100. So 2 times 6, 424, 0.24 kg meter square. So we have got the value of moment of inertia. But here this is hollow cylinder. So to get moment of hollow cylinder, there won't be 1. So you can remove 1 by 2. So this will get doubled. Here 2 will not be there. So in that case, this will become 0.48. Right? Because moment of inertia of solid cylinder is half mr square, and this is hollow cylinder. I did not notice. So it will become like this. So we have got I 0.48. So here torque we have already got 12. So 12 equal to I is 0.48 from times alpha. So from here we can get alpha. So you can evaluate what is alpha and then go to this formula. A equal to R alpha. R is this much, alpha you are going to get from here, put the value. You will get the answer. I think you have understood. Question number 14. To maintain a rotor at a uniform angular speed 200 radian per second, an engine needs to transmit a torque of 180 Newton meter. What is the power required by the engine? Uniform angular velocity in the absence of friction implies zero torque. In practice, applied torque is needed to counter frictional torque. Assume that the engine is 100% efficient. So, if you remember the formula I told you, like if you write work equal to force into displacement and you convert it into power, so you write W upon T equal to force into, this will become S upon T, which is velocity. So force into velocity. Now in terms of torque, W equal to tau into theta. If you divide it by time, W upon T, which will be power, so tau d theta by dt, and d theta by dt means omega, tau into omega. In our question, tau is given 180, omega is given as 200. So put the value 180 times 200 watt. Is it okay? Now going to next question. From a uniform disc of radius r, a circular hole of radius r by 2 is cut out. The center of hole is at r by 2 from the center of the original disc. Locate the center of the resulting flat body. Suppose figure is like this, its center is this. Here its center is at r by 2. This is say O, say we write it O dash, and now new center say O double dash. Here this disc is removed. Suppose total mass is capital M and the radius equal to capital R. So mass per unit area, say it is dm, which will be equal to m divided by pi r square. Now mass of portion removed, so mass of disc removed equal to area of disc multiplied by mass per unit area. So area of disc is pi r by 2, so r square by 4 multiplied by mass per unit area is m divided by pi r square, so we will get m by 4. So we have got mass of removed disc is m by 4. So mass of remaining disc, equal to m minus m by 4, that is 3m by 4. Now what we can do, we can take moment about this. So for this, suppose new center of mass lies here, so we can take moment. So moment about this, for this mass 3m by 4 must be equal to moment of this mass. So we can write taking moment about O. So here O dash OO dash times mass of remaining disk. So this is 3m by 4 must be equal to, here OO double dash, we are taking this portion OO double dash equal to OO dash times m by 4. From here m will cancel out. So OO dash is equal to, here 4 will also cancel out. So we will be left with OO dash divided by 3. But what is OO dash? Up to here, if this is R by 2, so here this will be how much? Actually, if you remember, this portion is radius R. So up to here, it will become R by 2, right? So this is R by 2. So just write here R by 2. So R by 2 into 3. So what you have got? R by 6. Did you understand? Should I tell you once again? I think thing is clear. Once again, let's do its a brief summary. So what is happening here? This is bigger disk whose radius is R. Now here small disk is removed. So radius will be R by 2. This portion is R by 2. So it's a radius of small disk will become R by 2, because up to here it was capital R, and then we have taken mass of bigger disk is capital M, and the mass of smaller disk we have got as M by 4, and then mass of remaining disk we have got, say, M double dash equal to 3M by 4, and then only one thing we did, we have taken this O dash, this as O and this as O double dash, and then we find the moment. So moment about center of mass, moment about this, moment about this of this point, and moment about this point of this point. So you can say, suppose we take this x, this we take y. So here again same thing we do, x times mass of remaining disks, that is 3m by 4 must be y times m by 4, and then our concern is to get what is x. So we write it 4 cancel, y m divided by 3m. But what is y? Y distance up to here. So definitely if total is r, so this will be r by 2. So here we write r by 2 in place of y, and m gets cancelled. So we get r by 6. So that is answer. Question is not tough. You can do it. Next question is, a meter stick is balanced on knife is at its center when 2 coins each of mass 5 gram are put, one on the top of other at 12 centimeter mark. The stick is found to be balanced at 45 centimeter. What is the mass of the meter stick? Here we are given a meter stick. Actually it will be balanced at G, but it is said that when 2 coins each of mass 5 gram are put on, one on top of the other at 12 centimeter mark. So suppose you start counting from here. Suppose here it is 12 centimeter. So at this point there are 2 coins, one over other, they are placed. Now clearly this will be 50 centimeter in the beginning, midpoint, because rod is uniform. But here mass is now 10 gram, 5 gram each of the 2 coin. So in that case, this balance point shifts to 45 centimeter. Suppose this is G dash, this is 45 centimeter. So now here, what is difference between these two? And what is the difference between these two? This is 50 marks, this is 45. So here G dash is just 5 centimeter, and G dash, and suppose say this is C. G dash C will be up to here, it is 12, and this point is 45, starting from 0. So this will be 33. Now, nothing more. We have to take moment. So consider it. So we write, let mass of stick is, let mass of stick is equal to small m. So when we take moment about this point, so we write 5 centimeter into mass of a stick into G must be equal to 33 centimeter this into mass of this 10 into G. Now we can cancel G, and then we can get M equals 33 into 10 divided by 5. 5 2s are 10. So this will be 66 gram. So I think you have understood. It's a simple question. Now we are going to take next question. The oxygen molecule has a mass of 5 into 5.3 into 10 power minus 26 kg and a moment of inertia of this much about an axis through its center perpendicular to the lines joining the two atoms. Suppose the mean speed of such a molecule in a gas is 500 meter per second and that its kinetic energy of rotation is 2/3 of its kinetic energy of translation. Find the average angular velocity of the molecule. So mass is given as 5.3 into 10 to the power minus 26 kg, and moment of inertia is also given. I equals 1.94 into 10 to the power minus 46 kg meter square. From here R can be found because I equal to mr square. Suppose the mean speed of such a molecule in gas is, here speed is also given. V is as 500 meter per second, and also another condition is given, and the kinetic energy of rotation. Ke rotation is equal to 1/2 I omega square, and kinetic energy is 2/3 of kinetic energy of translation. Ke translation is equal to 1/2 mv square, right? But there is condition. What is condition? This is 2/3 of Ke, so we can say that 1/2 I omega square is 2/3 of 1/2 mv square. So these are the conditions. From here what we can get? Velocity is given, I is given, so we can get R also. So think, give 1 minute and tell. Did you understand? So let's solve it. Here we write the condition 1 by 2 I omega square equal to 2/3 of 1 by 2 mv square. Our concern is to get angular velocity. It means we have to find out omega. So here 2 will get cancelled. So we will get omega square equal to 2 upon 3 mv square divided by I. Nothing more. Question simple. Just put the values. Omega square equal to 2 upon 3 m. M is given in our question 5.3. 5.3 into 10 to the power minus 26 into velocity is given as 500. So 500 square divided by I. I is given 1.94 into 10 to the power minus 46. Up to here there is no problem. I am just simplifying some steps and the rest steps you have to do. Omega square equal to 2 by 3 into 5.3. From here 5 into 5 I will write, and 10 power 4, 5 into 5 into 10 to the power 4 I am taking as power, and here minus 26, and from here this will become plus 46. Is it okay? Divided by 1.94. Further, if you wish to remove decimal, then that can be done like 2 into, write it as 530 into 25 divided by 3 into 194 into, here this is 50, 50 minus 26, 24 positive into 10 to the power 24. Now you can find the square root. If you find square root, so just evaluate it, find its square root, and here it is very obvious, 10 power 24, so square root means just power will get halved. So omega will be 6.75 into 10 to the power 12 radian per second. I think thing is clear. Thank you for watching. Team Educate